Yeah.
Hi, my name is Aaron Young. I'm a graduate student at Rutgers and mostly here. What I'm about to tell you is an overview of everything I do, and if anything I mention that interests you, please come talk to me. I'm usually on the 6th floor. So for my thesis, I've been using the Santa Cruz semi-analytic model developed by Rachel for years to make predictions for galaxies at high redshift. So because the model is very efficient, I can do controlled experiments and understand how the underlying physical processes would impact the predicted galaxy properties for galaxies over a wide mass range. And to take this further, I also added a reionization model to the pipeline, so I can do all sort of fun experiments with it. And a lot of my work, most of my work are advertised under the banner of semi-analytic forecast for JWST, but this is not only for that one telescope, but also for everything that comes beyond it. So I'm currently working with the JWST Cosmic Evolution ERS team and also the W1st Cosmic Dawn Science Investigation team to make these predictions. But if you're excited about this telescope, please come talk to me too. But while these amazing telescopes are sitting on the ground, I'm proposing the next project called Samurai, which stands for Semi-Analytic Model with Ultra-High Redshift Astrophysical Interplay, which is an umbrella project that I'm hoping to add a bunch of exciting physical processes to the SAM to make more robust predictions at high redshift to get ourselves prepared for the next 2 decades or more. So for observers, please come talk to me if you have any things that you want me to make predictions for you to help you. And for theorists, the special request is please come tell me what physical processes should I be adding to the model. I'm still looking for ideas. And I'm at the job market, hint, hint. This is everything you just heard is a preview for a talk that I'm about to give next Thursday at lunch. So if you're around, please come to my lunch talk. That's it.
We have plenty of time for questions. Catherine.
To Samurai? What are you going to put into Samurai?
I'm glad you asked. So the biggest idea that Rachel and I came up with is I'm hoping to put in the coevolution of the first star and the black hole seeds. I think these are going to be super important to properly model galaxies at very high redshift. But I'm also proposing a separate project that will go in parallel. It's called GRAPHT. So we're going to explore the formation of dark matter halo at high redshift. And the word graft is chosen as in grafting in gardening. So you can graft different branches to form new species of tree. And it spells GREFT. It reads gadget at ultra high redshift with extra fine time steps. Yes, I love acronyms. Hi, David.
Chiara.
Can you say a little bit about multi-messenger signals potentially? Sorry, that says multi-instrument, but I automatically read
No
multi-messenger.
worries.
But the question still stands. Do you have
Yes.
any multi-messenger work?
Right. So some predictions will be also made for ALMA using work from Gergo popping. So we explore emission from molecular gas and also nebula emission from high redshift galaxies, and hopefully get some nice spectra for predicted for future telescopes like Origins. And Lisa, yes. Thank you, Rachel. And
David.
So right now for W1st, we're planning an ultra deep field. And the idea is to do something that is multi-instrument, to get a target field and get LSST, radio, X-ray, get as many telescopes as possible to point to this field. It'll probably be the first thing that W1st will do. Actually, maybe spend 2 weeks to a month going deep. So, well, first just to advertise that to you, because it sounds like a really useful set of tools for making predictions for that. But one of the things we have been doing at the AAS meetings, and will probably continue for the next couple, is have community meetings to discuss what do we want. So, I mean, if you've thought a lot about that immediately, the question is,
am I invited now?
it's AAS meeting.
Okay.
You've been invited to every,
I can just go in and
just
crash the
go
meeting.
in, right? The idea is that this is open to everyone.
Okay.
And but since you're one of the people thinking deeply about this, that it's worth thinking about. And maybe you've already thought about, what would you want from an ultra deep field in terms of multi-wavelength? Is it important to get GRISM data on it? How should we proceed?
Thank you, David. I'm so crashing that meeting.
Let's thank Aaron again.